This video will conduct the operations it takes to fill out the metadata ops necessary to run our first project, programming project, for the simulator project, which is to upload the data and to display it. Let's take a look at what we've got now. We have completed steps 1 through 4 in the main here, and we have all the code done. We should never have to go back to the main function again. It's ready to rock and roll. We also picked up in step 5, we did the step 5 design right here, and then the step 6 operations of putting in the prints, really just filling in the blanks right there to make this happen. So we can actually run this right now, and we can see it work with what we've got with that right there. So if a user is unfamiliar with this operation, they might just type the name of the program. Again, in your particular case, it would be just OS underscore 01, 02, whatever for your project. But let's say they type this right here. Then they get this output right here, which in fact shows them how to make this work. Now, what we will accomplish in this video is we will make it so that we can do the -dm and display our metadata. We'll be uploading it and displaying it. As it turns out, we also have to count on the config being uploaded. We will show the code for that in another video. And for right now, doing the -rs simply displays a run simulator example. Let's go back and look at the code. Again, through step 4 in this main function here, and then we're going to do the show programming. Now, if I were in the Linux system, I would show you all the individual files, and we would do this the way it should be done and the way you must do it. You must have separate files. That said, I'm on a Windows system right here because the Linux gedit and editors are not very fast or effective for what we're doing, for what I need to do for this video. So I'm going to do it all in one file here, which is way the wrong way to do it, but it does guarantee that the code you see will be in fact correct and fully working as you go along. This is my configops file, configops.c file, as far as we're concerned. And for purposes of this particular video, my metadataops file .c is right here. So we're going to come down here and take a look at our first function. Our first function right here in the metadata file is add node. I will also note that from here forward in the file, all of the functions are in alphabetical order. Previously, I was putting them in as I needed them and as I was developing my design. Once I'm done, it's a lot smarter to have them in alphabetical order so you can find it when you have a pretty long file with a lot of lines of code. So this is going to start with add node, and we will go through alphabetically. It really doesn't matter what order you do these in, and that's the cool thing here. You are now effectively doing bottom-up programming, which is opposite of top-down, which was what the 6-step programming process does. But here, our bottom-up process is simply to pick up a function and just do it, following our specs. We have already set in all of our specifications, our step 5 statements here, and we don't have to be stuck in a particular place. We can just go right to the function and start filling it out. Let's do that. This function is the add node function and is in fact recursive in the sense that it's going to add every link onto the end. So we're going to start with our local pointer being assigned to null, which means we actually found the end of the list. We will go ahead and create memory for this, noting that we have to clean that up sometime later. We'll go ahead and assign all the values to this node. Now, when I first wrote this, I said 3 values, but as it has evolved, I actually have 7 values here, plus I will also have the next node for linking it, setting that to null. And then from there forward, I will return the local pointer because this would be the last one in the recursive line of operations. That said, once we fall through and if we're not null, then we're simply going to run our recursion here to link it to the next node of the current one, to the add node, all the way down the list. And then last but not least here, we are going to return the local pointer, and we can take out our temporary stub return. This is your add node. It is for adding the metadata nodes here and initializing them into, this comes from a given new node right here, but the node that is created here is the one that's going to go into the linked list. Let's move along. This is the next function up, clear metadata list alphabetically, but it's also the one that's going to clear out what we put in the add node. So we're just going to take this recursively. This is going to be almost the same recursively as the other one. The other one recursed all the way to the end of the list and then added the node on. This one's going to recurse to the end of the list and then remove the nodes from the bottom to the top. A cool thing you can do that recursion makes very easy. So I'm going to put in my if statement. If it's not null, then I'm going to recurse on down. And then what I'm going to do, this is going to recurse all the way to the bottom. But once it gets to the bottom and it does the very last one, then it will free that last one, and then it will fall back up and free the next one, and so on. It'll keep doing this recursively as it goes back up the chain of recursion. And then last but not least, this is a little bit of a bonus. The local pointer is really going to go away when the function goes away. That said, it's still better, I argue, to set it to null so that nobody else ever tries to access this data, because it is gone at this point and we don't want to mess anybody up. So I go ahead and add that assignment to null, even though it probably doesn't do too much. There's just a little bit of protection in there. And then last but not least, our return null for our temporary stub return actually happens to be the correct component here. And that is, we'll return null because once we're done with this, all the way back to the top, we will return null to the calling function, and it will say, yep, metadata list is empty, and it will assign that particular pointer to null, which again will keep people from trying to use it later on. So let's go ahead and go on to the next one. This is the display metadata function. It is expected that if this is called, there will actually be metadata there. So we don't really have an if empty component to this. However, we do have protection from actually breaking something in here, as you will see. So we'll start by displaying the title here. Easy enough with printf. We will loop to the end of the linked list, which is simply watching for null, and end our loop down here. And again, this loop will not go if it's null, so we won't break anything. We'll print the leader, which is the opcode part. It just says, hey, this is an opcode. We will print the PID, which is a process identification number. We will print the opcode command, and that will be a sys or mem or app or whatever the first three letter parts is there. We will check for the dev op command. Now the dev means it's going to be input or output. It means device. So if that's there, we will stick this in there with IO there. However, if it's not, we will just go ahead and put in an NA to fill that in, because there's several other commands other than dev. Having filled that part in, then I'm going to go ahead and put in the string argument for arg1, and that's a string arg1, and that would be the name of the device, for example. It would be a hard drive, or it might be monitor. It can also be memory access or acquire. So it could be several things but this is the string arg1. Right here will be the local pointer to int arg2. This will be the number of cycles. So the number of cycles would be the last number here for most of these. And then we'll put in that second argument, and there's really only a couple of places, one that's kind of hidden, but in the case of memory allocate or access, there's an int arg1 and there's an int arg2, and we'll collect those as needed. They may not be anything, they may be just 0. We will print the op end time, and as I mentioned in step 5, this will probably be 0 unless you actually use this for diagnostics somewhere later in your program. But the op end time starts at 0 before the program gets going. Then we're going to end the line. We'll do a couple of backslashes ends here to get a break here, and then we will go ahead and update our local node to the next node to start the loop over again. There is nothing really left to send back here. This is a display. It's a void return. So that's all we need to do on this one. The get command function is simply the one that gets the first three letters here. That's the app, the sys, the dev, whatever. And so it's just going to go up to actually a length of 3 right here. We'll loop across this. Now remember, this is coming in as a string now. We have the input string, we have a starting index, and we're going to return the ending index here. So inside this loop, we'll assign the character across, increment the index. I always set the next character to a null character whenever I'm doing string management as kind of a safety device. But this will go up to 3, and it will capture one of those 3-letter commands right here. And when it's done, it will return the index that it was done with, ready to go on to the next item. And at that point, we can take away our temporary stub return. This is the get metadata function. This is a big one right here. We went through already in our step 5. But basically, this brings up all the metadata and puts it into a linked list, and we pass it back as the opcode data head. Now we will set this up as a head pointer inside this function. but when we're done, we'll assign a pointer to the pointer so that it can be passed back into the calling function. Let's get started here. We will initialize our functions and variables. A read-only flag is R for purposes of our input. We're going to initialize the variables. Again, I would initialize these as I needed them in normal coding, but that takes way too long for a video. We will initialize our opcode and data pointer here. I'm going to set that to null in case we have a return error, up to the point that we actually allocate memory to it. We'll create a positive end of state message, just saying everything was okay till otherwise proven. We will open the file, and this is where we use our read-only flag. We will check for the file open failure. We will check for file access pointer as null. If it is null, we'll go ahead and update that end state message, and we'll return false from there. Now we're going to go for the first line here. We'll get a getAlign 2 from the file, bringing it in. We'll bring in all the data for a given line there. And what we want to do is see it look exactly like this, because if it doesn't, we're going to throw an error. So in this particular case, we're asking the negative question, did it not work? And if it didn't, then we will close the file, set the end state message, and return our false. Note at this point we have not created memory for this data structure, but we've made it this far. We have some confidence that we can do that. So we go ahead and allocate this to one new node pointer, which we will be using and reusing throughout. We're going to go ahead and get the first op command. And remember, the first op command, it gets a whole line. It gets one complete line of a given opcode to bring it in and gets us back our information from that. It actually places it all in that new node pointer there, and then we're going to go ahead and bring that on around. So we're going to update the start and end counts. We're going to count every time we come through this. We're going to check and say, do we get a start or an end? Because we want to compare those for equality toward the end. Now we're going to say, okay, did we get a good first op command? If we didn't, then we're going to close the file, set the opcode head to clear, which will end up being null, free our new node pointer, and this will free anything else that was already in there, copy the string with our mistake here, and then return the false. Looping across all the remaining op commands, we figured out the first one, seems to be working. We'll give this thing a shot, and we will say, okay, add the new opcode to the linked list. We right now just have it in the new node component here, new node pointer, but now we're going to go ahead and add it to the linked list. We will go ahead and get another op command, keep our track of our starting and our stopping, and now we're going to just keep going until this access result comes back and says complete opcode command found message for each opcode. And remember, we're getting back our new node pointer by reference here from the parameter, but this guy is going to keep saying, I got a complete opcode found. If it ever fails to do this, then, and it will at one point, it's going to say, hey, I'm at the last one, and that'll get us out of that loop. Coming down here, we're going to say, all right, fine. If we do get this part right here, then we know we've made it to the end of the opcode list and we're healthy at that point. These constants will be reported in just a moment. Then after that point, we're going to compare our start and end and make sure those are equal. If that's the case, we'll add that very last one that we got. We'll set our access result to no error. And that's going to matter a little bit later on because we're going to skip over some stuff. So we're going to head take a look here. We're going to get that last line and make sure that it is what it's supposed to be. And if it is, in this particular case, not what it's supposed to be, we'll set that access result to a problem here, and then we'll do the copy string of the mistake, and then we will fall through here. Now, at this point, I'm not shutting down the program or returning anything, and I'm just doing that because you don't need to do it in multiple places. We'll do it when we get down to it. If we did find the end, we'll reset our copy string and set that return state to false. So we are going to check this access result not equal to no error, which is the things we were setting up above. If it is equal to no error, then we can move on. But if it's not equal to no error, we're going to go ahead and clear that data list, set that to null, and then we're going to, either way, with or without the error, we're going to close the file. We're going to free our new node pointer that we used within this function. All the other nodes are still alive coming out of this, unless we had to kill them somewhere. And then we're going to set the local head pointer to a pointer to the opcode head. This is how we take a single pointer and pass it to a double pointer and pass it along there. And then when we're finally done, we'll return that return state, which will have the false or the true in it, and we can take out our temporary stub return. So what I want to do now is I want to come back up and look at how this no error, MD corrupt descriptor error, and that kind of stuff. I want to talk about where that came from. So let's take a look at that. This is a kind of a centralized header file that I use throughout the program. It enumerates your true false for your Boolean. Here's your config data type right here. And here's your opcode type right here. Now these are the things we've already talked about in the config upload and in the opcode upload, but these are where these are stored. The other thing we're doing right now with metadataops is that we've got some various components here that come back to metadata file access error, corrupt descriptor. These are ones that we were talking about back in the code here, and we're going to have available to those. And then I have the bad arg valve we'll see in just a few minutes. And then I've got my functions here set up for what we're doing. Some of these are not used in what we're working on, but you will always set your functions up in your H file so that they can be accessed by other files. Okay, coming back to the game here, we have completed the get metadata function and we can move on to the next one. This is the get op command function, which is almost as complicated as the get metadata function, but it's going to pick up one opcode and verify every part of it. And again, one opcode is exactly one of these lines right here. So we'll see that will play out in just a few minutes. So I'm going to initialize my function in variables. I set the command line length to 5 and argstr length to 15. These are the sizes that we find in the opcode type here. And so we have the sizes for those to work with that. We'll get the whole op command line at once. We get a get line 2 using out of our string utilities. Access result will tell us how it worked out. Again, we use those constants that tell us what results we did get out of a function there. And those are all in your string utils. So we're going to check for no error here. If the access result said it came through okay, then I will go ahead and get my 3-letter command. This is my get command function that we really have already picked up here. And it just gets that first command right here. That's going to get that first 3-letter quantity right there. And then I'm going to assign that to the string right there. Copy string to indata command. The indata is the node pointer we'll be passing back from this getOp command. If we failed there some kind of way, then we'll set our pointer to null and we'll return opcode command access error. Now what we need to do is find out, is it a valid command? We verify the valid command, and that's the sys, app, dev, CPU, and so on. And if that's false, then we will in fact return that we failed there with an op command error. So go ahead and set our struct values here. This initializes everything in this metadata structure at this point to get us started. We kind of already did that in the upload part, but this is guaranteeing that we're starting with a clean node here. We're going to check for the device command. We're going to say, hey, if it's a dev, and we're going to have actually several of these tests. So if it's a device command for dev, then we have to set in our in-out argument. So we'll pick that up right there, get string argument. And remember, get string argument picks up, starts at a given running string index, picks up whatever it's told to pick up, in this case the string argument, from the string buffer, and then returns the index it was done, so it can pick it up later. Once we've done that, we'll set the in-out arg. This is either going to be the word in or the word out. And then we're going to come here, and we're going to check and say, well, if it's not in or out, then we have a problem with the argument. We have a command arg error problem. So again, we're testing these one at a time. We started with our command, and then we check the in out because that's unique to only dev items. Then we'll go ahead and check here and try to go for the next string argument, and that would be the quantity that's process or monitor or allocate or whatever. And we'll pick that up, again using starting it here and ending here index-wise. We're picking these out of the string buffer that we've been using. We're going to copy the string from that string buffer, arg string buffer, into string arg1, and then we're going to check it. So we're going to verify first string arg, and if it's false, then again we'll return we've corrupted it here. So now we're going to check for sysend, which tells us, hey, we are there, we're at the end of that, and then we'll say last op command found message. This does two things. One, it passes this back, but two, it also tells us that we made it all the way through the list and got the right last item. So we'll go ahead and check here. We're going to check for app start. If that's the case, we'll put that in, get the number, because app start could have a 0 or a sum number behind it. And so we'll grab that guy, again picking off between string index, and it'll tell me what it got done with here. I'll check for bad argument value, just -1, I think, or something like that. And then I will set the arg2 failure flag to true. I'm not returning anything here because I'm going to kind of wound these up a little bit together. And I'll go ahead and set that arg2 with the num buffer, the number I got. So we always have to check when we get a number back, did we get a valid number before we put it in there? You'll see that happen again here. So for example, with CPU cycle time, okay, is it CPU? If that's the case, let's look at what CPU gets. CPU has a first string argument and one int arg. So we're going to grab that number there, check and see if it didn't work, set the failure flag if it didn't. Otherwise, we'll go ahead and put this in here with num buffer. I say otherwise, that's not true. It's going to put it in there anyway, but if it's bad, we'll be dumping it later. Come down in, now we've checked the CPU. So we come down here to check the device. We have already captured the string argument on this, on any of these here. And so now we're going to capture the number because every one of these has a hard drive or has some string here and then one number right after it. And so we'll come in there, do it again, get the number, check it. If it's failed, we'll set that. Otherwise, we'll put it into arg2 for this one. Okay, and again, we put this in arg2 for CPU. That'll be different than for device. We'll check for memory base. Now, if this is the case right here, if we have mem, this is a little different. Mem has an allocate, but it has two numbers, a base and an offset. So we're going to check this for their base number. Go in, get the number, check it and see if it failed. We will go ahead and set that value into our int arg2. And remember, I'm reusing that. Int arg2 for the dev, int arg2 for the CPU. All of these are different because the CPU will have this number, the dev, they all have one number that's added on, but they're added separately. So I am not overwriting this. Okay, coming back into here, we get that, we check it, grab it, check it for failed, set the failure flag, set that arg3. We had a str arg1, an int arg2, and an int arg3. And now, rather than having do returns from all of these things, this is where we're going to come through. We're going to say, hey, did we have any failures for arg2 or arg3? And then if we did, then we will return corrupt opcode command, arg error. Otherwise, we will say we found it, complete opcode found message. So we'll send that back, and we can take out our temporary stub return. And again, this was a big one, but this is the one we've got taken care of now to capture the entire opcode. Let's move on. This is our get number arg function. It grabs any leading white space and gets rid of it. And then it grabs the characters that we pull in and turns them into a real number. We'll come in here. We'll set up our function with variables. Our star number, I've actually made a pointer here, star number, so I can pass it back as a parameter. Our star number is set to 0. We will set the multiplier to 1, and you'll see its value in a moment. And we got a real quick loop right here. This is one that just simply says, hey, while we're less than or equal to space, which would be end line characters and that kind of stuff, or if it's equal to comma, we're going to skip over it. Remember that all of these other things could be ending in a comma, so we got to skip white space and the comma. So we increment the index and just go through the loop. Remember, we're starting here and ending here. All right, so we get into that loop there, and while it is a digit, in other words, okay, this is a digit, fine, that's a digit, fine, that's not a digit after that, so this is a digit, it'll just basically take the characters in while they are digits. So once it does that, we say even if it does it just once, we've set found digit to true. We set the star number, because remember, this is a pointer and I'm dereferencing it at this point to make it look like it's a real variable, times a multiplier, and the first multiplier through is just 1. So it's just going to say this times 1 plus the actual number derived from the character. Then what I'm going to do is set the index plus plus to move up our array, but I'm also going to set my multiplier to 10. When I come back through here, then I'm going to say multiplier times 10. This is going to say for example, it was 5. It's going to be 5 times 10 is 50 plus this number, and then maybe it's 4096. So 4 times 10 is 40 plus the 0. We add that in there, and then we multiply it by 10 again. We have 40. We add the 9, so it's 409, and so on. So that's how that works right there. And if we come through there, and if we found even one digit, we're good. But if we didn't, we're going to send back bad argval. And then when we are done with that, we will send back the index. We can get rid of our temporary stub return, and life is good. Let's go ahead and move on. This is the getStringArg function, which actually captures the string argument. String argument could be process or allocate or hard drive. So it's going to catch any of those strings there. And note, by the way, it has to be able to catch strings that have spaces in it. So it'll be watching for that. But what it does to start with here is it actually skips over white space in advance. It skips over white space and commas. So for example, in this one right here, I have a comma, skips that, skips the white space, and then it'll find sound signal. So this right here just skips over the white space and the comma. And then we come down here and set up our loop. And this one's going to be, well, we're not equal to a comma because in this particular case, we're going to watch for the comma to come back up after the text. And we will make sure that we're not going off the end of the string. So we go ahead and stick in there. We will assign the input string index over to our local one here. We will update both indices and set that next one, the stir arg, back there. All right, and then end the loop. And once we're done with that, we'll return the index. Remember, we started at an index, we're ending at an index and returning it. And note that we're also returning input stir as a parameter, and that's the reason we can do that because stir arg is in fact a pointer. All right, going home here, take out the temporary stub return and moving on. This is the very simple isDigit function. It simply looks at the characters between 0 and 9 inclusive. If that's the case there, then it'll return true. Otherwise, it will return false. We can just take out our little comment right here because we're done with this one. Again, an easy one. We can move on. These two, the update end count and later the update start count here, are simply ones that just get me some stuff out of my code that I didn't want to have to keep in there. This one right here very simply says, hey, is there an end in here in this opcode? If there is, I'm going to count it. Otherwise, I'm just going to return the count the way it came in. It stays the same. And so we can take this away, and that's all there is to that. And you can actually see here, update start count is the very same thing. It checks for the keyword start. If it is, it increments the count. Otherwise, it sends it back unchanged. This is one of the lookup functions that we have, verify first string arg. It's going to be pretty easy, although a little bit long because we've got several strings. We have process and monitor and sound signal and allocate and so on here. We'll have to test for all of them here. But that's all we'll do right here. We'll just say, hey, if it compares to access, allocate, and whatever, all these things, then in fact it will return true. Otherwise, it will return false. And that is all there is to that one. Verify valid command is also the same thing. It's going to check for string command arguments here. We'll take a look here. It could be sys, app, CPU, mem, or dev. And remember, those are our command quantities here. If that's the case, we'll return a true. Otherwise, we'll return a false. And that is all there is to that one. And that is all of our functions for the metadataops.c file. And again, you can see the value of putting in your statements in step 5. You can really see that the code is really just plugging things in, just following your instructions. As the functions get more and more complicated, you just follow your instructions. And as you get good at this and doing it in English, you'll be able to program in any language, and you'll be a lot more valuable in the conference room when you're talking to people about what you need to get done. The code is not important. It's your problem solving that they're going to pay you the big bucks for. This was our step 6 for the metadata ops process. And with the metadata ops process, we started filling in code, and all we really had to do for step 6 was follow our step 5 instructions. Life gets a lot easier this way and a whole lot less time spent trying to hack through code if that's what you're trying to do. We'll go ahead and wrap this one up here.